Today we're going to work with trig functions of multiple angles using real-world examples. Example 1 says, suppose that the height above ground of a person sitting on a Ferris wheel is described by the following function. H of t is equal to 18 minus 15.9 times the cosine of 2 pi over 5 times t. In this equation, h of t is the height above ground in meters, so let's underline that. And t is the time in minutes. The ride begins at t equals 0 minutes. During the first 5 minutes of the ride, when will the person be 27 meters above the ground? Round your answer to the nearest hundredth of a minute. So we are looking for this person to be 27 meters above the ground. And we know that h of t is the height above the ground in meters. So we want to start by taking this 27 and plugging it into our function at h of t. And we get 27 equals 18 minus 15.9 times the cosine of 2 pi over 5 times t. What we need to do now, if we notice that the t is within our cosine, we need to isolate the cosine function. To do that, we'll start by subtracting 18 from both sides. If I subtract 18 from both sides, I get 9 equal to negative 15.9 times the cosine of 2 pi over 5 times t. Be very careful that you don't subtract these two numbers first because you can't. This 15.9 is attached to the cosine. These are not like terms, so we cannot subtract them. Then we want to divide both sides by negative 15.9. And doing that, we get negative 9 over 15.9. Don't worry about simplifying it right now. And that's equal to the cosine of 2 pi over 5 times t. So what we have right now is we have our cosine isolated. But what's inside here is kind of ugly to look at. That 2 pi over 5 is attached to our t. The first thing we have to do is understand what is all of this stuff, this angle, have to be equal to. So to help us with that and to kind of take away some of the confusion, we are going to let u, and you don't have to use u, you could use whatever variable you want, equal that angle, which is the 2 pi over 5 times t. So I'm going to rewrite this, and I'm looking at negative 9 divided by 15.9 is equal to the cosine of u. Again, I just took this stuff and replaced it with a u to make my problem a little easier to understand. Then what I need to understand is what's happening here. I need to take the inverse cosine to get what I want for my answer. Now we're used to doing this with our special right triangles, which isn't necessarily going to work here because 9 over 15.9 is not one of our special right triangle sides. So let's think about this for a second. If we look at our quadrants, what's happening here is we have two angles that are being rotated. So there are 2 points that from 0 to 2 pi where I'm going to get a negative cosine value. Cosine is negative when the x value is negative. So I'm looking at these two quadrants, which means I have an angle here and I have an angle here. So I'm thinking about I had an angle rotation to here and then another angle rotation all the way to here. And what I'm going to be using is I'm going to be using my reference angles right here and right here, referencing this back to pi. Now before I talk about this problem right here, I want you to think about something else for the moment, which I think is going to help you understand why we're doing what we're doing. So I want you to think back to something with a special right triangle. So remember, this part right here is not really part of our problem, but I want you to think of the problem where the cosine of u is equal to negative 1/2. Okay, again, I just totally made this problem up. It has nothing to do with what we're doing here, but it's going to explain what we're doing from this step to the next step. With your cosine u equal to negative 1/2, that's your special right triangle. So what you would do is you would say, hey, cosine is negative in the second and the third. So you're going to draw your triangle here. You're going to label this as negative 1/2, that being 30, the inside angle being 60, and tell yourself, my reference angle is pi over 3 because of that 60 degrees. And then what you're going to do is you're going to say, hey, this is 3 pi over 3, which is just another form of pi, and I'm subtracting that pi over 3 from it. I'm subtracting that reference angle, which gives me 2 pi over 3. So I know one of my answers would be 2 pi over 3. I'm also in the third quadrant, so I'm also adding that reference angle on. I'm adding on that pi over 3, which would give me 4 pi over 3. which are my two answers. And we're doing the same thing back here in this problem, only we don't know what those values necessarily are because they're not going to be these nice reference angles. But note that up here in this work, we do have that reference angle. And that reference angle is the cosine inverse of 9 over 15.9. Just like over here where that inverse angle was that pi over 3, that inverse of 1/2. Okay? So we took the inverse cosine of a positive 1/2, which was positive pi over 3. And what's happening is if we're in this quadrant and this quadrant, we're taking pi minus that inverse function and pi plus that inverse function, just like we did here and here. So we can set up two different equations here. We know that u is going to be equal to pi minus the cosine inverse of 9 over 15.9. Move this up a little bit. And I also know that u is equal to pi plus the cosine inverse of 9 over 15.9. And this part here is only coming because of where it's lying, which is in the second and the third quadrant. Then I'm going to solve each one of these separately. So now I'm going to replace u with that 2 pi over 5 times t. So now I can say u is the same thing as 2 pi over 5 times t. And that's equal to pi minus the cosine inverse of 9 over 15.9. And the same thing goes over here. Replace the u back with the 2 pi over 5 times t. And that's equal to pi plus the cosine inverse of 9 over 15.9. Then in order to solve, so I'm going to solve each of these separately, if I want to solve for t, I have to get rid of this fraction. To do that, I'm going to multiply by the reciprocal. The reciprocal being 5 over 2 pi. So I get t is equal to 5 over 2 pi times that pi minus the cosine inverse of 9 over 15.9. This is what you are plugging in your calculator all at one time. Don't round anything beforehand. So pause it for a second, plug that in your calculator, and let's compare to make sure you're plugging things in correctly. If you did plug it in correctly, you should get t to be approximately 1.73, and that would be minutes. Then we're going to do the same thing over here, multiply by that 5 over 2 pi. So t is going to be 5 over 2 pi times pi plus the cosine inverse of 9 over 15.9. Plug that in your calculator. Verify that you got the right answer with me. If you did do that correctly, you should get about 3.27 minutes. These are our answers. If you have questions at any part, let me know.